Hi students, hope all of you are fine. In this lecture I will be going to discuss Picard's method of solving ordinary differential equations. Okay, so first of all I will derive that Picard's formula. Okay, then with the help of that we will be solving a problem. Okay, so let's get started. So this is basically your ODE, any arbitrary ODE, dy dx, and there will be some functions of x and y. Okay. So what we can do is we can write this dx here. So dy can be written as f dx, right? And if you now integrate both sides from some initial value to any arbitrary value, here also same arbitrary initial value of x to arbitrary value of x, then from dy you will get just y, right? So if you put the limit you will get y minus y0 and this thing will remain the same. Now just place this y0, move this y0 to the right hand side. So y is equal to y0 plus this full integration. But see here, the integration is with respect to x, right? So, but here in the function there will be some y. So how to solve? The integration is with respect to x only, but the function is function may contain both x and y. So what to do? So you need to take y as constant, then you can integrate, right? So y need to make constant. So what to do? As a fast approximation to this y value, what you can do is we can put y 0 in place of y. Okay. Y0 will be y0 is the initial value of y which will be given in the problem. So plug that y0 here. Then you will get a fast approximation. So fast approximation will be y1 is equal to the same thing you can write just in place of y, write y0. Okay. So y0 is basically constant. So we have fixed the value of y, then you can integrate. So this is the first part. Now as a second approximation, what you can do, since we got a new value of y, y1, so we can plug this y1 in this function. So we can plug this y1 in this function. Then if you plug this y1 in the function, then you will get another equation. This will be your second approximation. Okay. So in this way it will continue. So generally I can write as the nth approximation yn is equal to y0 plus this all thing will be given the same integration from x0 to x fx, and it will be yn minus 1 less than this dx. Okay, see here when it is 1 it is 0, when it is 2 it is 1. So you can write, if it is n, then you can write yn minus 1. So this is basically your Picard's formula, an iterative formula of solving ODE. Okay, and remember n should be greater than equal to 1. Okay, because here we have, if you put n equal to 1 you will get this, if you put n equal to 2 you will get this. Okay, so this is basically your formula. So in this way the derivation can be done. Pretty easy. Now let's solve a problem based on this formula. Okay, so they are saying use Picard's method to approximate y for x is equal to 0.2, given that your OD is this and your initial value of y is 1. That means value of y at the point x is equal to 0 is 1. That means this is basically your y0 and this 0 is basically your x0. Okay, and the function f is basically this x minus y. Okay, so this much given, and you are being asked to calculate y for x is equal to 0.2. So you need to find this y at the point 0.2. This is your m. Okay, so what you can do here is just write the formula from here to here. Okay, I have written the formula. Now What is y0? Y0 is basically 1, so you can write 1, and x0 is 0, so in place of x0 you can write 0, and other things keep it as it is. Okay, now what is f? F is basically x minus y, and if I replace this y by yn minus 1, then it will be x minus yn minus 1. X I haven't touched, it remains unchanged. But this one, instead of y, if you plug in yn minus 1, then this y should be yn minus 1. So you will get this. Okay. Now what you can do is, this x and dx, you can take it out, you can integrate separately. So if you integrate integration 0 to x dx, it is basically x square by 2. So 1 plus x square by 2 from this part, and the other term will remain as it is. Integration 0 to x yn minus 1 dx. Okay, and this minus I have written here. So now leave it there. Okay, the job is to plug in the values of n. So put n equal to 1 first, then 2, then 3, like that way it will proceed till you get a say 4 to 5 digit places become the same. Okay, so first of all put n equal to 1. So if you put n equal to 1 here, so y1 is basically 1 plus x square by 2 minus 0 to x. Instead of n, I have written n 1, because n equal to 1 here, right? So 1 minus 1 is how much? Is 0. So y0 dx. Okay. Now this 1 plus x square by 2 minus, you can write y0 is how much? Is given in the question, y1. So 1 dx, that means only dx. That means 0 to x, if you integrate, you will get only x. Okay, so this is your basically y1. Now what you can do is, you have been asked to find the value of y at the point 0.2. So what you can do, put 0.2 in place of x. Okay, so if you do that, you will get 1 plus 0.2 square by 2 minus 0.2, that will yield result of 0.82. Okay, this part is over. Then your task will be to put n is equal to 2. So if you put n equal to 2, this will become 1 and this will become 2, other things will remain the same. And in the next line, y1 is how much? y1, you have got the general equation, you got 1 plus x squared by 2 minus x. So if I write this in place of y1 dx, then you can easily integrate. Okay, so if you do that, if you do the integration and you solve it, you will get 1 plus x squared by 2 minus x plus x squared by 2 minus x cubed by 6. X squared is how much? x3 by 3 if you integrate. Now there is another 2, so 3 by 2 is how much? Is 6. Okay, and now in the next line, x squared by 2 plus x squared by 2 is how much? Is basically x squared. So 1 minus x plus x squared minus x cubed by 6. Okay, so you got a general equation for y2. Now your task is same. Here you put x is equal to 0.2. Here also put x is equal to 0.2. So if you put 0.2, you will get 0.83867. Okay, so this part is over. Now similarly, we will put n equal to 3. So here will be 3 and here will be 2, and y2, the value of y2, the equation, the formula, general formula, you got this. So plug this formula here, value of y2 here, and if you integrate, you will get this 1 plus x square minus x3 by 3 plus x square by x4 by 24. Okay, 1 minus x plus x square minus x cubed by 3 plus x4 by 24. Okay, and again if you put x is equal to 0.2, you will get 0.83740. Okay, just put 0.2 in place of x. Okay, now put n equal to 4 and repeat the process. So you will get 1 plus x squared by 2 minus, instead of x3 you will get this, you just need to put this one. This is the general value equation for y3. So plug this y3 value here, dx, and if you solve it, you will get 1 plus x square by 2 minus x. After integration you will get minus x plus x square by 2 minus x cube by 3 plus x4 by 12, and it is minus x5 by 120. Okay, and x square by 2, x square 2, again you can write x square, and other things will remain the same. Okay, and now again put x is equal to 0.2, you will get 0.837464. 0.837464. Now see the fourth digit. 4 digits after decimal point. 1, 2, 3, 4. So 0.8374. Here also, in the last case, you also got 0.8374. So what you can do, you can stop it here, and you can write the answer as 0.8374 up to 4 decimal places. Okay, you need not to proceed further. Okay, so basically this is the process. Simply plug in this formula and put n is equal to 1, 2, 3, like that way. Okay, and first of all, try to just solve this, so try to perform a small 2 or 3 steps such that it gets reduced. Here I have separately calculated x dx, okay, and then I have plugged in n equal to 1, n equal to 2, like that way I have proceeded. Okay, so you can do that also. So I hope this method is clear to you. Simple formula you need to remember, and then you need to just apply, and I have told you where to stop. Okay, just check the values at each iterative steps, what we have done throughout our numerical method lectures. Okay, so I hope it is clear to you. If you have any problem, you can call me or WhatsApp me. Thank you very much. Stay safe. Bye bye.